Welcome to This Explainer. Today, we are going to dive 13,000 feet underwater to investigate a mystery that might completely rewrite the rules of biology, evolution, and even alien life. So, have you ever wondered what actually happens in the absolute pitch-black depths of our oceans? Well, scientists recently found something down there that quite literally shouldn't exist, and it's actively challenging everything we thought we knew about how life survives.
Okay, let's dive right into this by first looking at one of the most alien environments we have right here on Earth, deep sea brine pools. Imagine a lake, but at the bottom of the ocean. I know it sounds impossible, right? But these underwater pools are so incredibly dense and toxic that a 5,000-kilo scientific lander can literally just float right on the surface. Any sea creature that accidentally swims into one gets an instant lethal shock to its system. But the craziest part? If a crab dies in there, its body can remain perfectly preserved for 8 long years, all while that highly acidic environment would melt a piece of steel 10 times faster than normal.
It is an absolutely massive contrast. Up at the surface, the ocean is full of oxygen and teeming with life. But these deep sea brine pools, zero oxygen, none. They are up to 252 times saltier than the regular ocean, and they're just filled with this lethal cocktail of methane and hydrogen sulfide. They're basically oxygen-starved death traps where extreme salt and bright minerals create these literal coffins, preserving dead organisms in perfect silence for years. Section 1. The Salty Ponds of Death. A time machine into our planet's past. So, to understand why these toxic underwater lakes actually matter, we have to rewind the clock about 2.7 billion years back. Back then, Earth used to be this toxic alien planet. We're talking an orange, methane-filled sky and oceans just packed with sulfur and iron. But then, this microscopic hero called cyanobacteria developed a random genetic mutation, photosynthesis. It essentially learned how to use sunlight to produce energy, and it just started releasing oxygen as waste. This great oxidation event totally wiped out the toxic-loving microbes of the past and paved the way for us. And it established what we thought was the absolute golden rule of biology. Earth's life-giving oxygen comes entirely from sunlight. Section 2. Mystery of Dark Oxygen, a deep-sea paradox. Fast forward to 2013. A scientist named Andrew Sweetman was exploring a region of the Pacific Ocean called the Clarion-Clipperton Zone, which sits right between Hawaii and Mexico. He dropped an automated benthic chamber, which is basically just a highly specialized isolation tank 5,000 meters down into the pitch-black ocean. His goal was pretty straightforward. He just wanted to measure how fast oxygen levels dropped as deep-sea creatures breathed it in. Because naturally, with zero sunlight at 13,000 feet, there are no plants making new oxygen, right? But here is the massive deep-sea paradox. The sensor showed that oxygen wasn't dropping at all. It was actually rising, in total darkness. Actually, at times, oxygen levels in the deep ocean were surpassing the levels you'd find all the way up at the surface. Sweetman literally couldn't believe it. I mean, he ran the tests again with entirely different equipment, just to be sure, but the result was exactly the same. They had stumbled upon dark oxygen, oxygen being produced without a single drop of sunlight. Section 3. The Ocean's Mysterious Batteries. To figure out how on Earth oxygen was being created without sunlight or plants, Sweetman teamed up with a chemistry expert, Dr. Franz Geiger. They set their sights on these strange, potato-sized stones scattered all across the seabed called polymetallic nodules. They collected these nodules, disinfected them with mercury chloride, just to completely kill off any possible oxygen-producing microbes, and then sealed them in an airtight jar of cold, dark salt water to perfectly mimic the deep ocean. The result? The oxygen levels tripled. By killing all potential bacteria and still seeing the oxygen go up, they proved the source was completely abiotic, meaning non-living. The rocks themselves were literally breathing out oxygen. So, how does a rock actually do this? Well, Dr. Geiger suspected they were performing electrolysis right there on the ocean floor. You probably remember this from chemistry class, but that's just the process of using electricity to split water into hydrogen and oxygen gases. But that raises a huge question. Where was the electricity coming from? They tested the rocks with a voltmeter and were, well, literally shocked. The rocks were producing 0.95 volts of electricity. The manganese in the rock acts as a positive terminal, just like it does in a standard battery. The iron oxide acts as the negative terminal, and that salty seawater serves as the perfect electrolyte. When these potato-sized stones cluster together, they can generate up to 1.9 volts,
which is more than enough to chemically split seawater into breathable oxygen. They'd essentially found trillions of underwater batteries. Section 4, the trillion-dollar threat, deep sea mining. Now, uncovering these batteries put the scientists right smack in the middle of a massive global debate. Why? Because those nodules represent an estimated $16 trillion. Yeah, trillion with a T. The Clarion-Clipperton Zone alone contains about 21 billion tons of them, and they are absolutely loaded with manganese, nickel, and cobalt. These are the exact metals the entire world is desperately hunting for right now to build electric car batteries and transition to green energy, which makes this specific area a prime target for deep-sea mining. And as you'd expect, this discovery has sparked a highly complex debate. On one side, you've got pro-mining organizations arguing that these minerals are absolutely vital for a green energy transition. They point out that they've spent millions researching sustainable extraction, and they've actively questioned the methodology behind the dark oxygen study. Meanwhile, marine scientists are arguing that these nodules are producing crucial life-supporting oxygen for the entire deep-sea ecosystem. And then you have the independent skeptics sitting in the middle, suggesting the lab methodology might actually be flawed, mostly because the extreme pressure of the deep sea wasn't totally replicated in the lab and hydrogen gas wasn't accurately measured.
But the scientists' fears here aren't without some pretty sobering historical precedent. To really underscore the environmental concerns, we have to look at the past. Back in the 1980s, a test mining operation was conducted in this exact area. The data shows that 70 to 80% of the organisms destroyed in that test haven't recovered. And it's been 45 years. The deep-sea ecosystem is just so incredibly fragile, filled with species that exist nowhere else on Earth. Decades after even a minor disturbance, the area still resembles a barren wasteland.
But hey, true science relies on rigorous testing and healthy debate, right? So this mystery is far from closed. The Nippon Foundation actually just awarded a massive grant to send equipment an incredible 11,000 meters deep. Their goals are pretty clear. They want to reproduce the original findings, finally measure that missing hydrogen gas to address what the skeptics are saying, and just double-check if microbes might still be playing some hidden role here. They are absolutely determined to settle this debate with hard data.
Section 5. Is there life in space? A cosmic question.
If these deep-sea batteries are truly producing oxygen without a star, it completely shatters how we search for extraterrestrial life. Think about it. For decades, our space telescopes have only hunted for aliens in the Goldilocks zone. You know, that perfect orbital distance around a star where temperatures are just right for liquid water. We've always just assumed that life absolutely required sunlight for photosynthesis. The rule was simple: no sun, no oxygen, no life.
But what we are looking at now is a brand new cosmic recipe for life. We already know water can exist in liquid form under the frozen crusts of distant moons. We know energy can be supplied in pitch-black oceans by the extreme heat of hydrothermal vents. And now we might just have the final piece of the chemistry puzzle. Oxygen can be produced abiotically by metal rocks in total darkness. Life might not actually need a sun at all.
So as the global community continues to debate the future of deep-sea mining and the delicate ecosystems sitting way down below, it leaves us with one staggering, genuinely provocative question to ponder. If life on Earth can thrive off underwater batteries in total darkness, how many invisible, sunless worlds are quietly breathing out there in the cosmos? Thank you so much for joining me on this explainer. Keep questioning everything, and I will see you next time.